So let's go through a couple more example problems just to get more practice, since some of these problems can be fairly challenging. This is one of the more difficult ones. So let's start by rewriting what we have. So it's 64 to the 5t squared plus 3t. And you can see many different ways to write this. So like an earlier problem, you might be tempted, since we have a sum of our exponents, to break this up into a product where you have the same base for each of our expressions. However, looking at the answer choices, it doesn't seem like we want to break this up for at least a couple of them, and this one is similar to what we have here. So it looks like in this problem, a lot of it is built on just manipulating 64. For instance, 128 up top and 2 down below, that would divide to 64. So that's kind of a clue for the path that we're going to take for this one. So in this problem, it may actually be easier to start with the answers. And let's just start with the first one. We have 32, and actually let me use a different color so we can differentiate what we're doing here. This is our answer. So we have 32 raised to the 5t squared plus 3t, all divided by 4 to the 5t squared plus 3t. And we have two different expressions where they're raised to the same exponent. So recall, when we have division, let's say we have a over b, and if they're raised to some power, that this exponent essentially distributes to both of these. And this would just be a to the c over b to the c. So we're essentially starting from here and we want to go backwards. Since we have division and they're different bases, but they're raised to the same exponent. So we can apply this and rewrite it just as a quotient of the two bases. So we have 32 over 4 raised to the 5t squared plus 3t. And 32 over 4 we can simplify, that's just 8 to the 5t squared plus 3t. Well, we have 64 to the 5t squared plus 3t, not 8. So this one is not correct. Now let's move to the second one. And in our second one, we'll use a different color again. So in that one, we have 128 to the 5t squared minus 3t over 2 to the 5t squared minus 3t. And we're going to apply this same rule, essentially the exact same logic for this one. Both expressions have the same base, or excuse me, both expressions are raised to the same exponent but have different bases. So we can rewrite it as a quotient of the two bases, 128 over 2, and they're going to be raised to that same exponent, 5t squared minus 3t. And we can simplify this since 128 over 2 is just 64. So we have 64 to the 5t squared minus 3t. And you can see that this is not correct either because of the sign. It should be plus 3t, not minus 3t. So that second one is not equivalent. And so we just need to check this third one. So let's make a little bit of space and we can work on that. So for that one, we have 2 to the 5t squared plus 3t multiplied by 4 to the 5t squared plus 3t. And for this one, they don't have the same base, but they're raised to the same exponent. So it's very similar to that rule with quotients. But now remember, if we have a product raised to some exponent, that the exponent goes to each factor in the product. So that's what we have here. They have different bases, but they're raised to the same exponent. So we can combine it as a product of the bases. So 2 times 4 raised to the 5t squared plus 32 or 3t. And 2 times 4 is 8. So this is 8 to the 5t squared plus 32, which is not what we have since our base should be 64. So that one's not equivalent either. In fact, this one, 8 to the 5t squared plus 3t, notice that's what we got when we did the first one. So the first and the third one, these are equivalent to each other, but none of them are equivalent to this first expression here.